So Apple has come out with some pretty incredible research, and I think this has the AI community completely divided because it fundamentally shifts what we know with AI models. And I think this genuinely could change everything because of what this research is currently suggesting. So I'm going to break this all down for you because this is largely one of the biggest papers that have come out recently, and it's fundamentally quite surprising. So essentially, Apple Research has come out with this paper called GSM Symbolic, understanding the limitations of mathematical reasoning in large language models. Okay. And basically, the short summary of what this paper is suggesting is that it says that we hypothesize that current LLMs are not capable of genuine logical reasoning. Instead, they attempt to replicate the reasoning steps observed in their training data. So basically, this paper is trying to suggest that current large language models, as they are, models like GPT-4o, Claude 3.5 Sonnet, that these models aren't as smart as we think they are, and they are not reasoning through any kind of problem. The only thing that they're doing is just statistical pattern matching, which means that these models are simply not as smart as we once thought they were, which would have severe implications for certain things moving forward. Now, the research dives into a few things, which I'm going to explain, and it's pretty simple to understand. So let's get into why this is really impactful. So one of the things that we use to do to assess how models score on their reasoning, or essentially assess how smart these models are, is by doing certain benchmarks, okay? And one of those benchmarks is called the GSM 8K. This is called the Grade School Mathematics 8000, which is 8,000 grade school mathematics question. The Apple researcher says here that when OpenAI released GSM 8K 3 years ago, GPT-3, one of the first iterations of the GPT series models, scored 35% on the GSM 8K test. Today's models, with 3 billion parameters, are surpassing 85%, and the large ones are hitting 95%, okay? But he argues that has reasoning really improved? Like, how much of this is genuine logical / symbolical reasoning versus pattern recognition / inadvertent data contamination or overfitting? So basically, what he's stating is that, if we look back to the smaller models like GPT-3, which were 175 billion parameters, scored 35%, okay? And today's smaller models, like the tiny models from today that are only 3 billion parameters, are surprisingly surpassing 85%. And even the larger ones are hitting 95%. But he's like, okay, we've made such incredible progress in such a short space of time, but we need to realize how much of this reasoning has actually improved, okay, versus data contamination, which basically means that the data that we use to actually train these models, more parameters, more data, the data that we actually use, how much of this increase in percentage is actually related to data contamination, where unfortunately some of the data from the test sets and the answers have slipped in to the training data, so the model essentially remembers what it was trained on and isn't actually getting smarter, and how much of this is also just pattern recognition. So what we can see here is we can see this graph, which shows us the GPT-3 models from 2021. And then, of course, we can see the state-of-the-art models in 2024. And we can see that the GSM 8K accuracy is just going up completely, okay? We can see that this is continuing to go up, okay? But this is where this Apple team of researchers decided that, okay, if we want to test to see if these models are actually increasing their reasoning, what we need to do is we need to come up with a new benchmark, okay? And this new benchmark that they've used is one that is a little bit different, okay? And it's literally a little bit different because what it does is it changes things ever so slightly. So they said, introducing GSM Symbolic, our new tool to test the limits of LLM in mathematical reasoning. We create symbolic templates from the GSM 8K test set, enabling the generation of numerous instances and the design of controllable experiments. We generate 50 unique GSM symbolic sets, essentially like GSM 8K examples, but with different values and names. So all they did was they took the test sets of the GSM 8K, they took a few of those questions, and they decided to change the values and the names. So basically in the math questions, sometimes you're like, Jimmy has 5 apples. So what they decided to do was they decided, okay, I'm going to change the names. Okay, so from Jimmy, it's going to be John, and from apples, it could be oranges, and from 6 oranges, it could be 7 oranges. So they decided to change the values and the names. And if these models are truly capable of reasoning, they should be able to handle these problems fine, as long as we've, just changed the names and the numbers and not the actual problems. So essentially, you can see right here that this is the GSM 8K on the left-hand side. We can see that the values that are going to be changed are located here. We can see that Sophie, then of course her nephew, then we can see 31, 8, 9, Sophie, nephew 62. So those are the only values that are going to be changed with regards to the changing. And you can see right here that the GSM Symbolic template, of course, the name, it has the family, the total, and you can see it changes these within, a certain range. And this is how the template is constructed. Now, it's important that you understand that all they've done is just change the names and the values. But the crazy thing about this was that when they changed the names and the values, we can see that there was essentially a large discrepancy in terms of the results between what the models claim to have got from various research labs versus what they actually tested and they actually got. So he says here that current accuracies on the GSM 8K are not reliable. We observe a large performance variation. For example, Llama 8B scores anywhere between 70 to 80%. Phi 3 scores between 75% and 90%, and so on. And for most models, the average performance on the GSM Symbolic, which is just a variation of a test that they already took with different names and different values, is lower than the GSM 8K. We can see here that there is quite the discrepancy between the reported values and then of course the actual values on the GSM Symbolic test, which is quite surprising. And we can see that the actual test results are in the dashed line. So if you want to look at what these models got, we can see what these models got here in the dashed line. Then we can see the variations of what these models got, which is between 90 to 98. Then of course 70 to 80%. Then of course from here, this one looks like from 70 to 85%. So they're starting to question, why on earth is there such a giant discrepancy in terms of these models' results, purely based on the fact that the only thing that has been changed is of course just the names and the values. And this is a bigger chart, and we can see that some of the models that have the largest drop are Phi 2, Gemma 2, and of course some of these other models. And it seems that these smaller models are going to be the ones that probably have a lot more overfitting, a lot more data contamination, amongst other things. So we can see right here that the researchers are stating that the fragility of supposed LLM reasoning. LLMs remain sensitive to changes in proper names, for example, the people, the foods, the objects, and even more so when numbers are altered. And he's basically asking here, would a grade school student's math test score by, vary by 10% if we only change the names? And I think it wouldn't. Like if you gave someone a test and you only change the names, would the outcome of a mathematical based question change by 10%? I don't think so, considering the fact that it's just a name, which could mean that potentially these LLMs are simply memorizing things or doing pattern recognition. And this isn't good, because if this is true, it would mean that these models aren't as smart as we think. And it might mean that we need better architectures for solving the reasoning issue. Now, there's a lot more that goes on here. We can see how this has been affecting other models with these changes. We can see that we have these changes plotted here. So for example, we can see the GSM 8K is the dashed line. Then we can see if we change the names, there is a slight drop. If we change the numbers, there's another drop. And if we change both, there's an even bigger drop. So this is something that is quite surprising, because it means that these models are getting confused once these names are being changed. It doesn't really make any sense whatsoever. Now, we also have something where he decided, okay, what if we adjust the question difficulty? We're going to introduce 3 new variants of the GSM Symbolic to study model behavior, removing 1 clause, GSM M1, and adding 1 clause or adding 2 clauses. Basically, it's just the GSM Symbolic, which is just 1 change. And then, of course, the GSM Symbolic P1, which is an increase in difficulty, and GSM Symbolic P2, which is, another increase in difficulty. Now, of course, this specific result I don't think is too bad because, of course, as you increase the difficulty, the model should go down, and this is what we do experience here. But the difficulty doesn't seem to be too much, but there are really large drops in performance, which does also beg the question, are these models truly understanding what's going on? Because there are a few difficulties added and there's such a large drop off. We can see that, of course, the O1 models do seem to perform a little bit stronger, but on other models like GPT-4o and GPT-4o mini, there are a lot bigger drops. Now, this is where the research starts to get really crazy, and I start to question whether or not these models truly understand what's going on, because the researchers decided to do something even crazier. Okay, so this is where they state, this begs the question, do these models truly understand the mathematical concepts? Introducing the GSM No-Op, we add a single clause that seems relevant but doesn't contribute to the overall reasoning, hence no-op. So basically, what they've decided to do here was to have these, traditional GSM 8K exam questions, but what they did was they added something that wasn't relevant to the question really at all. So we've got one example here, and you're going to see the results of this, which are pretty crazy. So it says Oliver picks 44 kiwis on Friday. He then picks 58 kiwis on Saturday. On Sunday, he picks double the number of kiwis he did on Friday, but 5 of them were a bit smaller than average. How many kiwis does Oliver have? A statement like, but 5 of them were a bit smaller than average, doesn't impact the number of kiwis that you do have. Like, it literally doesn't impact that, the mass at all. Okay, it doesn't matter if it's bigger or if it's smaller. A kiwi is still a kiwi. Okay, and the crazy thing about this is that it says we added seemingly relevant statements to the questions that are in fact irrelevant to the reasoning and conclusion. However, the majority of models fail to ignore these statements and then blindly convert them into operations, leading to mistakes. Okay, so what these models will do is they'll be like, okay, if 5 of them are smaller than average, and then they get really, really confused where they should just disregard that because it's not relevant. But take a look at the performance drops on models when this is done. The performance drop is just, this is insane. Like, this is incredible. You've got the GSM 8K. If we look at the GSM No-Op accuracy, the performance drop is around, even on O1 preview, the Orion model that we think is probably the best model that currently exists, there is a 17% drop in the GSM 8K to the GSM No-Op accuracy, which is pretty outstanding. And the reason I say, and the reason I highlight the O1 preview model, which is this model right here, is because this is the model that is supposed to have the best reasoning capabilities. There shouldn't be like such a large slope here, because what we have is we have a consistent drop in performance across the models, despite these benchmarks having irrelevant questions. What we should see, if O1 preview is as good as reasoning as OpenAI claims, this bar should be, up here, because these models work through the problems step by step in order to get to the final solution. I'm not sure how OpenAI trained O1. There's a lot of secrecy behind it. But if a model drops its reasoning capabilities 44%, 32% for GPT-4o when seemingly, irrelevant information is added, I think this is absolutely remarkable, because how many times have we added data to a problem to ChatGPT, to GPT-4o? We've provided it with so much context, and sometimes, arguably sometimes, some of that context is completely irrelevant. And a 30 to 40% drop in terms of the reasoning output, that's pretty awful. Like, that's pretty bad. Like, there's no way to put this other than this is a truly shocking find, in my honest opinion, because I wouldn't have thought that adding such irrelevant statements would have resulted in such a large performance drop. And what's crazy about this is that we see a similar performance drop for GPT-4o to O1 mini. We can see O1 mini's drop is at 29% and GPT-4o's is at 32%. O1 preview does do better at 17.5%, but I wouldn't be expecting that big of a drop for a model that is specifically trained to reason, okay? And we can see the other open source models here, A lot of these other models are pretty smaller, but I am glad that they did include the O1 series of models, because that would have been a glaringly obvious thing to do, considering it's just trained on reasoning. So the craziest thing about this, which is why I said that this could genuinely fundamentally change everything, is because he says here that can data, models, or compute fundamentally solve this? We don't think so. They state that scaling, data, models, or compute cannot fundamentally solve this issue, okay? It says that OpenAI's O1 series is performing better, but still suffers from slight performance variations. And O1 preview shows significant improvements, but it still suffers from silly mistakes like this, okay? You can see that this problem just blindly applies the inflation rate. So the question is, Liam wants to buy some school supplies. He buys some erasers that now cost $6.75 each, 10 notebooks that now cost $11 each, okay? A ream of bond paper that now cost $19. How much should Liam pay now, okay? Assuming that due to inflation, prices were 10% cheaper last year. When you read this question, you have to disregard the fact that due to inflation, prices were 10% cheaper last year because Liam is buying this stuff now. So this bit right here, you just completely disregard that, okay? Most humans who look at this kind of problem are going to completely understand that, because you're going to be thinking, wait a minute, why would I look at inflation last year? Okay, disregard that. How much does everything cost now? And then you answer the question. So, of course, we can see here that, you know, when this model is doing the reasoning, we can see that it says step 1, calculate last year's prices after reducing the current price by 10%, which is just not what you would do at all. You're not even supposed to do this step. So the model completely gets this wrong. And the question is that if these models were actually good at reasoning, if they truly understood what was going on, would they make such simple mistakes? He then goes on to state that understanding LLM's true reasoning capabilities is crucial for deploying them in real-world scenarios where accuracy and consistency are non-negotiable, especially in AI safety, alignment, education, healthcare, and decision-making systems. And that is truly important. If you are going to be saying that, okay, we're going to get to AGI, we're going to be potentially deploying this kind of technology worldwide, we need to make sure that like a simple, input into a prompt cannot throw off the model by 40 to 19%. You have to understand that one of the reasons that these models aren't used in certain environments is because there's certain, applications where the degree of accuracy that you need to have is very close to 100%. And anything that deviates from that is going to result in a catastrophic impact. For example, the amount of planes that go down, I think it's like 0.00. It's ridiculous, okay? Like the failure rate for certain parts is insane. And the point I'm trying to make, guys, is that we can't have models that fail like in 90% of scenarios if something is added to the end of a prompt, which the model cannot distinguish if it's relevant or not, okay? And I think that's really important to understand, because now we can understand, okay, if this is the case, maybe we're not going to, put AI in certain areas like maths or certain reasoning areas because it fundamentally doesn't understand some of these issues. So he goes on to state that developing models that move beyond pattern recognition to true logical reasoning is the next big challenge for AI. So the reason that this is crazy is because this could be a massive setback for AI. If this paper has essentially proved that these models aren't capable of reasoning, it would somehow mean that OpenAI's recent series of O1 models just simply aren't that good. And I know that that might come as a huge surprise, but it might mean that potentially these models are just simply bigger, which means they have more data and potentially more data contamination. I mean, OpenAI doesn't always reveal how they train the models. They don't say, where they got their data from. There's no third parties that can analyze these data sources. Of course, these are private companies, but I think this paper is really important because the sooner we can bridge the gap and solve this problem, that's going to be, the moment we can actually start to speed run and get to AGI. Now, he also says that, of course, overall, we found zero evidence, okay? And that's an insane statement. We found no evidence of formal reasoning in language models, including open source models like Llama, Phi, Gemma, and Mistral. and of course, leading closed models like GPT-4o and the O1 series. And one of the statements that you might want to take away from this is that their behavior is better explained by sophisticated pattern matching. So fragile, in fact, just changing the names of the question can alter results by 10%, okay? So understand that this is just, truly shocking research, genuinely, because, I mean, if you take a test and by changing the names, 10% drop, that's crazy, okay? Especially for the future implications for where this stuff is, needing to be used. I mean, just think about it, guys. I mean, imagine applying your problem to a model that you say, okay, this model has a 95% rate, but because you input, your problem with your name and your numbers, the model manages to get it wrong on a variety of different occasions, okay? It might get it right 80% of the time, but 20% of the time, the reasoning steps are wrong, which means, are you going to catch that 20%? Are you going to be aware of that? I mean, this is something that's really important for any of you using AI in certain use cases, because AI is generative and of course the results are not always the same. So it says we can scale data, parameters, and compute, or use better training data for 5.4, Llama 4, and GPT-5. But we believe, okay, and this is Apple's research saying this, that this will result in better pattern matchers, not necessarily better reasoners, okay? So this is absolutely crazy. This is crazy. They're basically saying that, these models are essentially just pattern matchers, which is, I mean, it's quite surprising. Like, genuinely, this is surprising. I would have thought that, okay, this could happen for models like GPT-4o, GPT 3.5, the open source, open source models, but for O1 series, that's genuinely crazy. Like, when we look back at this chart and see a 17.5% drop, that's a bombshell paper, okay? And we can see some more results for the O1 mini here. You guys can screenshot this and look at this. Now, the craziest thing about this is that this isn't the only paper that actually talks about this. There was another paper that, it just genuinely didn't get that much attention. I'm not sure why, but this Consequent AI, they said functional benchmarks for robust evaluation of reasoning performance and the reasoning gap. Now, essentially, what they did was pretty much the same thing. And we can see here that they, kind of found that there was a reasoning gap of 58% to 80% among the state-of-the-art and open source models on static benchmarks, okay? It was pretty crazy. It was pretty crazy, okay? So it said the reasoning gap here, we can see that OpenAI's GPT-4 was 58.35%. And basically, before I get into actually the results, they just did the same thing. They said that models that solve a reasoning test should exhibit no difference in performance over the static version of a problem compared to a snapshot of the functional variant, which is where, once again, they just changed the numbers where they could. And these are the results that they had at the time. Now, this is a research paper from earlier on in the year, which is why we only see GPT-4 there, and we see all of these, Anthropic's Claude 2.1. But the point is that this research, unfortunately, has existed for quite some time, and we just haven't got to see this yet. So this is largely one of the most surprising things. I know that there is also this simple bench reasoning benchmark by AI Explained, and this is one that has simple reasoning problems, which is actually quite similar to the GSM Symbolic kind of benchmark, in the sense that it's a bunch of different questions that involve, the similar reasoning. And I would like to see where O1 is, but this one doesn't have any data contamination because it's a private data set. But I do think that this is very interesting, okay? And I think that Apple research coming out and saying that, their behavior is better explained by sophisticated pattern matching that is so fragile that, can, be affected by a 10% drop just by changing names. It means that, even if you scale data, even if you change parameters, even if you have more compute, okay, this problem isn't going to be solved. So right now, I think that this is probably gonna, lead a lot of people who are in these AI labs take a look at things once again, analyze the things that they've been doing and think, okay, maybe we can't just scale up data. Of course, there are new scaling laws with test time compute, which certainly could solve this. I think with test time compute, maybe, with inference, you could have a better reasoning steps that analyze the problem multiple times. There was a research paper that actually did talk about how when you ask the models to repeat the question, sometimes they do, catch these mistakes. But I think that that will be really interesting to see how they solve this problem. I mean, there's a variety of ways that they could solve this. I mean, maybe they're going to have to ask the AI the question, I don't know how many times they're going to have to ask the AI the question, pick the best response. I mean, there's a million different ways that, they could tackle this. But I think this is bad news because, yes, it means that we're the wrong path, but it's also good news because it now means that, okay, if we know what the problem is, now we at least know that, okay, we can actually fix the problem and move right in the right direction. So even though it seems that maybe we were, actually doing an off-ramp, it seems that now we can see that, okay, if there's such a big discrepancy, we need to figure out how we can solve this. So let me know what you guys think about this research from Apple. I thought this was absolutely crazy. Let me know what your comments down below are. Do you think these models are reasoners? Do you use them to solve your reasoning problems? And I'd love to hear your thoughts in the next video.